Thanks, Stefan. Yep, so I'm from NCSA. I'm giving, I think, what is our last site update here for the conference, and the only NSF site conference, so not as large as some of our DOE site updates that we've been receiving this week, but hopefully still useful and exciting for some folks. So the outline for today, I'm going to be going through, touching on a lot of the topics, hopefully from an operational sense that have been discussed throughout this conference, some multi-tenancy stuff that was talked about in depth on the technical side this morning, and also client-side data compression that we've been experimenting with, as well as a brief amount of our experience with DNE3 as well, and also some S3 stuff that we've been doing with Versity on our file system. So first off, just some of the highlights, the high-level stuff for Lustre usage at NCSA. We ran GPFS for a long time when I first got there, and we started doing Lustre back in earnest. Again, we ran it with Blue Waters, and people thought like, oh, that's all we did was Lustre because of that, but actually every other file system besides Blue Waters was GPFS at the time, and so we kind of came back to Lustre again here in 2021, and at this point we have 5 namespaces under our management that are Lustre based that aggregate to about 36 petabytes of capacity, which is about 60%. So I think in the last like 3 months, we actually, Lustre crossed the 50% boundary for us in terms of our capacity and how it's deployed. Of that, about 5 petabytes is usable NVMe space, and a growing amount, obviously. The aggregate IOR across all these systems, when we benchmark them, is about 1.2 terabytes per second, with the fastest being about 850 gigabytes a second, and the largest being about 25 petabytes. These are not the same file system. The fastest one is much smaller than our largest one in this case. All of them run Lustre 2.15 or 2.14. Xscaler 6.3, as I think Peter alluded to in his talk yesterday. We call it Lustre 2.15, even though if you look at the version of the RPMs, it's still 2.14 on there. So, and we're very much fabric agnostic. Not that it's our choice as the storage team, but those that choose and deploy and architect the compute environments seem to have a varied interest in different network technologies, so we have to support all 3 major-ish fabrics that are out there right now. So that's somewhat a challenge, but also something that kind of keeps us busy. So I'll talk through here some details on our 2 largest file systems that are out there in our data center right now. The first one is the work file system that is underpinning both Delta and Delta AI. Those are 2 separate NSF grants and 2 separate systems that are scheduled independently, but share a common storage platform. We procured 12 400VX2s as part of the Delta AI procurement. And sorry, Steve, we do actually, in our case, share MDSs and OSSs, not by choice. It was a budget plus capacity plus other constraints need is the only way to do it. Huh? Yeah, exactly. So, yeah. And then we also have 3 7990Xs that do all of our capacity for that. All these appliances directly connect into the Slingshot fabric. For a while, we had to bridge them in via an Arista switch and then convert them, that Arista would then bridge into the Slingshot fabric, but now we are all direct connect. We still leverage the TCP driver in Lustre to do that. That still works pretty reliably and pretty performantly for us. We're happy with that to the point that we're not going to try and go down the KFI LND route, at least for now. We'll stay over on TCP until we have a reason otherwise. All these storage appliances, though, do connect to their own Slingshot fabric that has its own fabric managers, is independent and isolated from both compute fabrics, which gives us some nice autonomy when Slingshot decides it wants to be fun. We don't have to kind of deal with that when the other clusters have their issues. The storage fabric appears with each Delta and Delta AI Slingshot fabrics at about 1 terabyte a second. I think it's 40 links per interlink between each of the clusters, so 80 total interlinks there. And it's a cable spaghetti to make that happen there. So yeah, so this is our fastest file system on the work NVMe side. So across that entire namespace, both the HDD and NVMe tiers share the namespace together. They have 48 MDTs. We set up a directory structure here where we have work HDD and work NVMe. Lets the users kind of know what to expect a little bit when they're running. Their allocation directories are down beneath that tier, and they're backed by the respective OSTs from those appliances. Then we leverage OST pool quotas to limit them. A lot of allocations will be allocated on both. They'll get an NVMe allocation, they'll get an HDD allocation. So it might be like work HDD BBKA and work NVMe BBKA. And then we use pool quotas to pull that out and limit them on each of those tiers respectively. And then we're also altering that PFL that allocates data to the right OSTs here on the NVMe tier to do compression. I'll talk about that here later, but this is where we're experimenting with compression, is on that NVMe tier here in Delta. So, and we also have Taiga, which I think I talked about last year a little bit in my talk. It's our global file system. It did finish its growth here. We have it for an NVX2 in there as well. I'm not going to read through all of these different systems that are in there. We tried to have a nice standard building block based on the 400NVX platform, but there was an 18K that was just, it was getting ready to get orphaned, and it was too nice to do that too, so we pulled in. We needed the space anyway. Taiga rests on a back-end HDR fabric. I don't have the map in my slides, but it's in our documentation. There's a lot of stuff that spiders off of this HDR InfiniBand network, and it makes extensive use of LNet routing, at least for us anyway. There's 17 LNet routers that connect Taiga to 6 different distinct high-speed fabrics across the center that make up, it appears with Ethernet, IB, and Slingshot fabrics of varying speeds. So multiple speeds of Ethernet, multiple speeds of IB, Slingshot as well. So it's very well connected. There's a lot of different LNet networks that are in play there. We do also leverage Lustre node map on this file system, and I'll talk about that again here in a little bit. This is the file system where that happens as well. And we're actively doing a lot of work to make Taiga available to researchers in numerous mechanisms all in one place. A lot of why Taiga was deployed, why we designed it, why we put it in this place is that a lot of our researchers are doing compute in a lot of different areas in a lot of different ways, and they do data acquisition at the edge. A lot of agriculture research, for example, happens in the state of Illinois. And there's people like flying drones out over cornfields and creating scans and things like that, uploading data via cellular connections and stuff coming in all that ways. And so we try and find a way to have a very common data platform that is available for researchers to both ingest data, compute on that data, and then share that data without having to copy it between different file systems that are built for each of those purposes. So we go through all these protocols here. I'll talk a little bit about how we do the S3, but we do obviously a lot of stuff with NFS Samba. We do subject ourselves to that. Researchers can mount a 25 petabyte file system on their laptop from the airport in Toronto if they connect to the VPN. Will their performance suck? Yes, but they usually just want to edit a text file for the most part there. And users have honestly not really complained in that regard. A lot of them have been very thankful for it. We've got a lot of positive feedback from that. We're also right now getting ready to explore a more web gateway-based access to Taiga as well. For those, if there's anybody else here from like a research institution that does a lot of work with Google Drive or box storage, a lot of those companies are making policy changes to those terms and conditions underneath a lot of research R1 institutions. And we're actually, Taiga is kind of becoming a lifeboat in a lot of ways for those researchers. And some of those researchers, we were watching Globus transfers from this file system to Google Drive or to Box. They were just doing backups that way. So those users are usually fine, but we have some researchers who just aren't quite as familiar with things like Globus or other command line interface tools, and they want to have like a web gateway type of access to their file system. They can browse in a web browser and see data in their project allocation. And so hopefully we'll have a chance to present on that effort soon. We're about to get underway on architecting and rolling that out. It's one of our near-term goals here for Taiga. The other three file systems underneath our management that are Lustre-based are not anything necessarily special, but we do have one in our control data environment that handles EPHI and CUI data. We also have it deployed here for Scratch. We have an early 4NVX3 system that was mentioned, I think yesterday. One of those that shipped this week is coming to our data center, hopefully via a carrier here soon. And then also Lustre underpins the Scratch file system for our Innovative Systems Lab, where our Innovative Systems team does lab early testing on new accelerators or new CPUs, and they do benchmarking on new hardware. And they just needed a Scratch file system, and so Lustre underpins that operation for us as well. So our experiences here with NodeMap in production. NCSA has will operate its own LDAP services. The University of Illinois is not keen for us injecting tens of thousands of users that run on our active national systems into their AD services. For good reason. It's logical. We didn't expect them to. But for that reason, we've run our own LDAP for a very long time, and we will continue to. But as we bolster our support for the university system, we also do stuff with the Illinois Active Directory based users. And so Illinois Active Directory has been used historically on systems that are deployed specifically for Illinois researchers. This has been handy for them because instead of making them get NCSA accounts, it lets them continue to use a common identity that they're used to using for all their other Illinois needs. They don't have to track another username password combination. Especially it can be frustrating to them sometimes because maybe their Illinois username was taken by somebody else in NCSA LDAP from another institution where they had the same username, and so that can be frustrating there. So all the systems that we deploy for Illinois tie into their authentication, and that should make things a lot easier, especially for things like domain joined machines. We talked about Samba access a little bit earlier. It's nice to have those things all kind of aligned there, and that's how things have kind of operated historically. But these has led us to deploy different file system solutions for each of these environments. This file system either serviced a compute environment that was tied to NCSA LDAP, or a compute environment that was tied to Illinois AD, never the twain shall meet. Just because even though a lot of us do have usernames that align between the two systems, that doesn't mean our UIDs align. They definitely don't at all. And GIDs are nowhere close to being managed and segregated between those two authentication domains. And so we had to keep things separate. But back here in January, a bunch of semi-trucks backed up to the campus's data center, and we hauled all of the Illinois research computing infrastructure into our petascale facility. And now it is in there, which allowed us to more easily connect it with Taiga. And so back in early 2024, we decided, hey, we need to go down this node map route and make this possible. And so all the Illinois systems sit behind a set of 4 LNet routers that translate between our HDR 200 backend fabric for Taiga and the 200 gigabit Ethernet HSN for those systems. And then all the clients that are behind those LNet routers are subject to the node map policy that we created, which currently we have about 9,000 UIDs that are being mapped, and then about 600 GIDs that are being mapped. We expect those numbers to grow. I mean, these are higher numbers. My screenshot that I grabbed for the slides, I think, are as of 2 or 3 days ago, and I checked just before this talk. We didn't quite cross 9,000. I was hoping we get the next 56 users. Not quite yet in the node map. But yeah, so this is growing on a regular basis, on a daily basis, as more and more groups join the system. Tangentially to this effort, the University of Illinois system is doing an Illinois Computes initiative, which is rapidly onboarding the number of users onto our systems, which is great, but we're pulling in a lot of new users here, which is leading to this. So we do have automation that kind of handles all of this for us, so that when new users or groups are added, that are added to the map automatically, and we kind of keep up with those changes. Right now, on about a 30-minute cadence, we keep that node map in sync with what's going on in AD. We're mapping those accounts into our NCSA LDAP system, and so a lot of Illinois users have an NCSA account. Oh, all these Illinois users have an NCSA account, though. They just don't know they have an NCSA account. It's just kind of a shadow account. But we're actually doing some work right now that hopefully should speed this sync time up to about every 10 minutes, where we can kind of keep a little more in sync with what's going on in the directory service. We still get some complaints where somebody they get added to it, their pre-I adds into a group via the group add portal, and they're sitting there running, the groups command on their terminal, groups. Hey, I showed up. I want to get into the project directory, and then they can't, because as soon as they show up in AD is the first that we can ever potentially know that they need to get added into node map. And so we're trying to shorten that iteration on our node map edition, and we hope to get that down to about an every 10-minute run here in the next month or so with some enhancements that we're making to that code. But we're also working through that inverse of that process, removing users. Universities are very transient places. Researchers come and go very often. And while it's handy to know who data was owned by in the past, historically, we do also want to keep this node map kind of clean. And so we are kind of working through the policy decisions still on how we remove users from this node map. When do they get revoked, and how do we trigger that action? Likely, we're going to do something like a quarterly cleanup, where we have a script that will audit that, and then we'll give us a list of users to review, and then we'll approve that list and kick them all out of the node map. Additionally, this problem is about to get worse or more fun for us here. Part of this is we're doing a $20 million machine for the state of Illinois' university systems. Each of those campuses have their own AD structure, and so we're about to have even more fun. We look forward to the dynamic node mapping stuff that was talked about earlier when that lands in 2.17. So we're so far very pleased with how this has been working. We were a little concerned with the scale as to how this was going and how long it would take mounts to occur on the system, but so far we've had a very, very positive experience with node map here in production. It's worked as it's been portrayed, and so far it's been very fantastic for us. Just having something like dynamic node map and node map ranges will help us manage things here as time has gone on. The way we have done the shadow users and shadow groups in our LDAP has set us up so that we will be able to do GID ranges or UID ranges when that time comes that we can do that, so to make things more concise. Pivoting away from node map, another thing that we've been doing a lot of work with is the transparent data compression. I think Peter called us on this one back in early fall and asked us if we wanted to try and test out this feature, and we said sure. So the Delta project office was very happy with this. The external advisory board, the EAB for Delta, was very happy to hear about this. Obviously, there's never enough NVMe capacity for our researchers, and then A big gain for this was that they didn't have to do they had no Lustre to do anything. They didn't have to do a lot of work on their own. It kind of came for free on the back end where that compression was happening. And so this is being done under work NVMe allocations. So far, we've only done it on a couple of subset of the allocations on the system. We're kind of slow rolling this out here to make sure that it doesn't cause any issues. I think I talk about it here. No, I don't know. But our application support team did do a good job doing some benchmarking on client-side data compression to make sure they didn't cause any issues that they could see, but they only could test so many codes, and Delta runs hundreds or thousands of workloads. So we're kind of taking this step-by-step basis and deploying the projects as it makes sense too. So we started this testing in fall of 2024. Initially, when we started testing, this feature was not available for ARM clients, which made it a no-go at the start because we have Grace Hopper on Delta AI. And so we were able to test this, though, from the Delta side on the x86 clients and see, we started playing with how compression would work out. We didn't deploy in production. We just kind of carved off an area of the file system for us to do this testing. And so while we waited for ARM support, which we knew was coming pretty soon, we decided to figure out what compression algorithm we wanted to use in this case. So obviously, our factors in that decision were we wanted to, have as much compression as possible for obvious reasons, but we also didn't want that to, of course, impact our workloads too much. The vast majority of the compute nodes in Delta and Delta AI are GPU equipped, either quad or octo-way GPUs from a variety of generations. And so the compute engines on those are mostly the GPUs. Users get allocations on those nodes and they run GPU codes. They don't do a lot of work that taxes the CPU in many cases. Not never, but not often. So there's usually idle CPU cycle on these nodes. And then there's also a large read-write imbalance on these machines. There's a lot more read than there is write. This is, I think, the last 30 days of read-write ratio on that file system. And so you see that stark difference there. And kind of based on this, we kind of settled on LZ4HC compression to be chosen there on the file system. We've ended up seeing better results kind of than we anticipated. We were curious how much this data set would actually compress. Like I said, we've only rolled this out to a subset of our allocations so far, about 34 allocations, I think, as of last, and out of like 1,200. But what we've seen so far is about a 1.3x reduction on these, and this is on real user data, actual allocations on the system that we've scanned the results for so far. And as expected, kind of, we looked through these, we were on a file-by-file basis in some cases to see how things were compressing, what was compressing, and as one might expect, either a file is decently compressible or it's just not at all compressible. It's kind of a binary state, depends on what kind of data is in that file. But on the overall aggregate, seeing about a 1.3x was actually fairly encouraging for us. A lot of this is image data that we see. People are training on large image data sets, or audio or video that cannot be easily compressed is already pretty well compressed in general. So we're so far very pleased with what we're seeing on compression there. Like I said, our workload performance team did some benchmarks. They pulled out 7. They tested the big ones, PyTorch, TensorFlow, some big ones like that, and they found no meaningful impact to their workloads that they ran in terms of performance. We just had enough idle CPU cycles in these nodes to process that without much penalty there. So hopefully here by the middle of the summer, we're going to have this rolled out fully to all allocations on the system. We're hoping here sometime in early May we'll have it become the new default for new allocations that get onboarded, so that we're not like fighting an ever-growing number of allocations as they keep coming on. So we're about ready to set that as the default tentatively here as May 1st, so that all new allocations get this in their PFL by default when they're provisioned on the system. So, so assuming we find no issues between now and then, that's how we envision that for rolling it out there. Also on Delta's file system, I mentioned we have 48 MDTs on that file system, a very large number of MDTs. We do balance these right now, 1 per stack, as I mentioned on the 4 NVX2s. Each one can hold about 260 million inodes per MDT, which gives us about 12.3 billion total in this file system. We have our max round robin set to 10. It did start at 6 when this file system first went in production. We did bump that up to 10. And it's been working pretty well for us. Right now we have about 2.3 billion inodes in use on this FS. And you can see that distribution breakdown there by percentage on our targets. We have a 3 there that kind of outlie there between 27 and 33%. We had just a couple users that have very deep, wide directories and just got beneath the 10. They went really deep and then went really wide on us. But otherwise, we have fairly compact. We're not quite seeing as good of a 3% balance as Steve saw, but still very respectably balanced on our system. We're very happy with how it's been balancing out. Most of our MDTs sit in very comfortable range and are very well evenly used. So that one's working for us as advertised as well. And it's been working very well on our performance benchmarking as well for MD test workloads and for also some ML perf stuff that we've been running. And then lastly, I want to talk about S3. This has kind of come up a little bit, I think, in some other talks, just in general. An approach we've been taking with S3 on top of Lustre for us is we've been using the Versity S3 Gateway, which is an open source tool that Versity worked with, I think, Lanel on, if I'm not mistaken. Some folks from Lanel here can verify that. I think they worked with them on that protocol. This has been gaining popularity for us because a lot of our users are wanting to kind of see their data via S3. Hosting and sharing data sets for science gateways is a lot of times done via S3, and there's been a lot of push within the NSF community to do a good job of supporting science gateways. So we do see a lot of people that are getting excited about S3. Also, like I mentioned earlier, like with Taiga, we do a lot of remote data acquisition, either from things out in the field or things just from around campus in the labs. And a lot of these tools are adopting S3 as a common way to transfer data and do data protocols for transfer. So it's handy to have S3 for people that are doing data acquisition. A lot of our researchers in the engineering department are very happy about this as well. And also for sharing training data sets, there's a lot of work that we're doing within NCSA right now to store common AI data sets on our file systems for researchers to use so they're not duplicating like a common Hugging Face repository in their each and every project directory. And so we're looking at hosting those via S3 stores as well. And then also integration with data backup and data movement tools. If people like to use rclone or other things like that. There's also some researchers that, some departments on campus that for a variety of reasons need to store some of their data somewhere else, but they want to replicate their things into our services. And so using this gateway with S3 as a data transfer protocol has been very helpful there. So we're very excited about using S3 for some of these things. We co-deploy the Versity Gateway right now on our Globus DTN nodes, so it kind of rides along there on the DTN infrastructure for Taiga. And allocations can request an S3 endpoint for their allocation. For the whole part of it, sometimes they want to expose just a sub part of their allocation. And they can also expose this as read-only or read-write. It just depends on what they want to do. A lot of them are starting to do that on the read-only side, especially for data publication as well. That's another place where we see this is people want to make that bucket be available for allocations for references in papers and things like that. We currently orchestrate the deployment of this with Ansible and systemd unit files, but we're hoping here, a lot of our development in this area has been focused on the scalability of this service in front of Lustre, so we want to move towards some orchestration via Kubernetes as opposed to doing this with our Ansible plus systemd unit files. It's just not quite as scalable here as we want it to be. Also automating user serviceable key management so they can do more fine-grained access controls on their buckets. We also want to kind of tie it better into allocation provisioning. Right now, users have to request it as part of, when they get an allocation, they have to opt in, they have to reach out to us to get that S3 integration. We want to actually just allocate that manually for them, automatically for them when they get an allocation on the system. They don't have to ask anymore. Just by default, they will get S3 access to their allocation as well for those that want to use it. As we work on the orchestration tools for this, we hope to share those back with the community as well, so that others can maybe use it, fork it, or do other things with it. We're really excited to hopefully contribute back to the community in that way as well, both for Lustre users and those who use the S3 gateway in front of anything else too. So, and that is, I think, the end of my slides for today. So.
Questions for JD?
You mentioned wanting to provide a web interface to access one of the file system Taiga, I think. What do you have in mind to implement that?
Right now we're looking, the first thing that we're looking at is Nextcloud as an option to put in front of that. That's a common one. Leveraging, I think it's I don't like it from a performance perspective. Everything in my HPC body doesn't like it. But we're going to see how that does. We're concerned about performance and scalability of that, but we're looking at using the external storage providers in Nextcloud to hook into Lustre that way. The biggest issue with doing this, and there's a lot of tools out there that can expose storage as a web interface. The common problem with a lot of them is that they want to run as Apache or Nginx or things like that, but we need them to be running as the user that is doing this work, so the data ingested via that method is owned properly, permissions are respected as they traverse the directory tree structure. A lot of people have allocations in multiple parts of the tree, and so we need to have it, wherever this is, honor those things, and so that's kind of where that's kind of coming from there on that side. So it is tricky, we're hoping that we can like find that solution there in Nextcloud for that, but we will see. We don't anticipate it to be like obviously the primary method of access, kind of how SMB is for us right now. You know, we monitor the telemetry on our SMB servers. Like no one's ever doing anything crazy over those connections. It's mostly like a, hey, I want to open this file and text edit it, you know, and then save it back and things like that. And we think the web interface will probably do more data ingestion. People want, you know, want to upload a bunch of files from their computer or something like that, but they're not going to do a lot of super IO intensive things via that portal. So we're hopeful it'll scale, but yeah, we'll report back how that works out here soon. So.
I have a question. How did you come up with a max inherit of 10 for DNE v3?
Is it maxed up to 10?
Yeah.
We looked at, so we started off with 6, and then we had some users that had some very deep directories, and we did like a scan with Robinhood. We kind of took a look and tried to figure out where depth maxed out for us, and we settled on kind of 10 is where that depth is. For us, we do ours from the root. I like Steve's idea where it actually does the round robin from a lower level of the tree. We didn't think about that when we did this, but because the first 3 levels of our directory structure are kind of eaten up by work, HDD or NVMe, and then the allocation directory, and then within each allocation directory, there's a user directory. So it might be like work, NVMe, BBKA, and then it's a username directory, like Malone 12, and then real science starts to happen at that point. So 10 might sound extreme, but it actually 4 or 5 levels down is when you actually hit like real science data that can actually start to balloon and go wide on that. So.
I was just going to ask, with the S3 gateways, did you put anything in front of them like a load balancer, or is it sort of just per allocation you go to this?
Right now it's round robin DNS that sits in front of those. Yeah, we are toying with a load balancer there because it can put a lot of, you know, we do run Unbound on those things that you can put some loads on DNS to do round robin if you're doing, you know, a lot of different, you know, a bunch of object puts or things like that. So we do anticipate trying to put a load balancer there in front of that, but right now we have not done that yet. So yeah.
One thing I was going to comment about the space balancing and the depth and all that, like I personally think it should just be like -1 out of the gate, and then change it if you know, you think that there's an issue there. Like it seems like these questions, like how many levels deep, like unless you have an exhaustive scan of the file system, like you're never going to find every single corner case. So it's like, why not just have it always do that? Like, that's kind of like what I think I've mentioned in WAM Club before, is like, just pick the optimal thing and just stick with it. Yeah,
I think we were under the impression, and Andreas can correct all of us for sure, is that there's a performance penalty for a remote creation underneath, and so that we at some point we wanted to limit that because we figured that, you know, we don't want, if you did it for forever, like we're always hitting that performance penalty of remote directory create, and so we wanted to kind of do what we thought we needed to do to balance usage, but then also not go any deeper than we needed to. We'd like to, I mean, I don't disagree with that sentiment, I guess, but if there's no performance penalty, but, and I'm not sure what the penalty is necessarily there, so.
I mean,
Yeah.
Yeah, so I mean, the remote make tiers are about 10 times slower than a local make tier. And so I think in configurations like yours where you have, you know, 40 or 50 MDTs, you're still ahead by doing that all the time because you know, it's 10 times slower, but you have, you know, 4 times, you know, factor higher than that number of MDTs, so you're always gaining performance by going wider. Yeah. But on small systems, you know, if you're doing it all the time, you're not really getting more out of those 4 MDTs or something like that, right? So, you know, maybe we need to make it, you know, scaled based on the number of MDTs, or I've been thinking for a long time that 3 is probably too low. Right. I mean, originally we were sort of thinking, you know, it'd be like the Lustre mount point and then like a user directory and then, you know, some application directory and then like output directories. And those ones would get round robin, but, you know, maybe we should make it up to 6 or 8, right, by default. And then, you know, there's a balance there because doing it all the time does eat into your performance.
Yeah.
Okay, other questions for JD? No, thank you.